Hello everyone, my name is Maria. I'm from Nomadic Labs. I'm head of marketing communications, and today I'm with Francois Thire, who is software engineer and technical leader of data availability layer. We're going to talk about the DAL. So could you please make an intro to this feature, tell us more about it, and especially deep dive into the role that it plays in the proposed Tezos X roadmap?
The DAL stands for data availability layer, and it's also something that we call rollup booster for smart rollups. It helps to increase the throughput of smart rollups. The DAL is a core component of the scalability proposed roadmap Tezos X, and as such, the DAL will aim to reach even larger TPS with a high capacity such as 100 megabytes per second.
How that project actually kicked off, how it all began. Can you bring us back to the first pages of DAL?
In 2021, we started to shift the projects in the core development of Tezos towards scalability. We started first with Rollups that aims to put off-chain the execution of transactions, but there was still a roadblock with the bandwidth as the L1 that were limited. And so a bunch of engineers coming from Nomadic Labs and Tech started to work closely with Arthur to design a solution. And this solution is now what we call Tezos DAL.
So one of the important decisions was to have a dedicated DAL node for the project. Can you please walk us through this decision and why it was so important?
Indeed, with the scalability roadmap of Tezos, we started to multiply a bit the number of nodes that we need to use. First, people were very familiar with the Octets node, and it was rather clear for us that when we add new features such as the smart rollups or the DAL, we likely need to have other nodes. For example, one of the reasons is the fact that Ocamo, which is the programming language we use to develop Octets, at that time did not support a feature that we called parallelism. And so having multiple nodes was a way for us to ensure that we could isolate things.
So one of other decisions was to spend significant time and effort into improving the peer-to-peer network behind the DAL.
One major component of this data availability layer is to run another P2P protocol alongside the P2P protocol used for the L1. One of the properties that we have for the P2P protocol on the L1 is that any node, when you connect on the L1, will receive and share all the informations. But of course, it introduces some bottleneck or limit because everyone needs to see the same thing. P2P protocol we wanted for the DAL was different because to make it scalable, we wanted to have an efficient way to share the data among the different peers that would connect onto the network. And so in particular for bakers, which is one of the even maybe most important actors for the DAL, we wanted them to receive only a portion of the data that would be sent over the DAL. And so at the end, the P2P protocol that we use, which is called GossipSup, enables this to have something that we call topics, but mostly what it enables is to share efficiently the data between the people that will send some of the data and people that will receive it. And at the end of the day, you don't have all the actors of this network that receive everything. And it's very important for us to have a scalable peer-to-peer network.
Could you name other major design choices made and how those impacted the project in general and its development?
Another design choice that distinguishes us from Ethereum or Celestia is that at any time or any block produced on the L1, multiple producers or slot producers or multiple people that wants to send data over the DAL can send them, and it's not restricted to one, allowing us to have anybody send data over the DAL. To gain some flexibility, we released the DAL with not the full capacity. We wanted to test it first. To be able to have this modularity, it was important for us to keep some slack for bakers to fetch the data over the DAL. And so there's some latency between the time where some people send the data over the DAL and the time where they are attested and then they can be imported by the rollup. It's a trade-off because you have more latency on the DAL network, but at the end of the day, you have also more bandwidth or more capacity, so you can send more data. Thanks to this trade-off, we are able now to increase step by step the capacity of the DAL. At the moment, we have a bandwidth or a capacity of around 500 kilobytes per second, which is 10 times the capacity of the L1. And our goal now is to have in 2026 100 megabytes per second.
DAL enables the future-proof scalability for Tezos, and it's the cornerstone of Tezos X. But what's next? What are your plans for moving DAL forward?
One of the trade-offs we made was related to the P2P protocol. So we started with an efficient and complex P2P protocol, but there are things where we did something a bit simple to start with. In particular, if you want to support a larger capacity and the sampling, we know that we need to change some of the components of the P2P protocol. I think the major component that is missing actually in the picture now is the sampling, which is expected to be released in 2026. The idea of sampling is to have all the nodes running on the L1 network, but also use the DAL network. And this way you have this link.
If we want to, let's say, try to compare the solutions that already exist in the industry and where they're going, where DAL sits.
So the two main competitors we are looking at the moment are Ethereum and their data availability solution for scalability called Sharding, and the other one is Celestia. However, there's something that I think is unique on Tezos at the moment. It's this peer-to-peer network. It's something we have now on mainnet, and I hope we will be able to keep this advantage in terms of feature in the next few years.
Is there anything else you'd like to add about DAL?
I hope we will be able to make DAL an important feature for Tezos, but also more relevant at the blockchain ecosystem, because I really believe we have something unique here.
Thank you very much for watching and staying with us and discovering DAL. Have a great day.